All right, so we're going to talk about system platform and cyber secure architectures and basically building a system for defensible security. Get right into it. So the basic requirements of a defensible control system are we want to be able to restrict general access. In other words, just because you can write to one thing doesn't mean you get to write to anything. And everything needs to be encrypted with certificates. Every tag, item, attribute, element, whatever you want to call it, of the control system, the right target must be able to evaluate whom is issuing the right. And I like to talk about the 4 aces of control system security. You need to be authenticated, which means your access has been granted after some username or identifier is known. You are authorized, means you're allowed to do what you're trying to do. And sometimes you must authenticate yourself again when you wish to do that. You must be approved. Sometimes it requires more than just you agreeing to do this. And the second actor must be able to approve your thing. That could also is demanded by the right target. And it could involve multi-factor authentication as well. And every action must be archived into a mutable 21 CFR Part 11 logging mechanism that is write once, can never be changed, can never be modified, and that logging must be done by the target, not by the originator. So everything that you have in your system, all protocols, graphics, APIs, external clients, must be required to enforce this model without any configuration at the origin of the write command. So Aviva, we've taken security very, very seriously. We were certified in October 1st, 2016. We're the first industrial software to have the ISA secure label. We've basically taken this thing to a whole new level of approach to security that is going to give you, right, looking at the system holistically, right? So the greatest threat to your control system is not external factors. While those are important to protect against, the greatest threat is the authorized actor acting inappropriately, either by accident or confusion. Maybe they're disgruntled or it's malicious. Maybe they've been compromised somehow, like their kids got picked up on the way to school by some nefarious actor, and now they're being forced to do something that they wouldn't do normally. Any software that gets inserted within your intrusion protection boundary. This is kind of addressing air gapping. Air gapping is a complete fallacy of security. Air gapping is a myth. Software can easily insert itself beneath the air gap. And then what do you do? Reliant of the business IT domain. And it's not because the business IT guys are the bad guys. It's just because as a domain, as an OT level network, we are typically connected to the business network. Therefore, we must protect against who is our endpoint. Who are we connected to? And that's typically the IT department. Doesn't mean they're bad. It means we have to defend ourselves against them if they ever get compromised. Port restrictions is not a good security policy. It's a good thing to have minimized port profiles, but we'll talk about that. Obscurity as a security policy. You know, the days of when this was an industrial protocol and nobody knew how to construct it, those are all gone. Everybody knows everything about everything these days. And just because it's something that's not common is not a security policy. You should have domain isolation between your control world and your business world. And any open protocols operating beneath your security model need to be locked down and secured. Things like Modbus, that all that is required is a properly formatted message. You can't let these guys just be operating. So my greatest example of the authenticated actor acting inappropriately was on the morning of Saturday, January 13th, 2018, 8:07 a.m. A guy at the command and control center on the island of Oahu been staring at a button that he said he'd been looking at for 5 years, and he decided that he was going to push it. And that button sent a message to every television, radio station, cell phone, freeway overpass sign, hotel PA system in the state of Hawaii. And that message said, ballistic missile threat inbound to Hawaii. Seek shelter immediately, or seek immediate shelter. This is not a drill. So half the state went crazy, panicking, looking for the shelter. The other half said, hey, is the surf up? Let's go surf. It's our last chance to catch a wave. He just basically told the entire state he had 10 minutes to live. And it took 38 minutes and 13 seconds for them to issue a retraction. Do you think there should have been another person who should have authorized this? That it wasn't something someone could have just pushed the button on indiscriminately? And we have the Colonial Pipeline example, which is the business IT threat. The business system was breached. The control system in this example was never penetrated, but they couldn't separate themselves from the business system. So they had to shut everything down, and they had to pay a big ransom, and the FBI partially recovered it, and we all know the story, but it never should have happened. So as we look at general system security, we need to have an umbrella of certificates applied to our SCADA system. And with Aviva, that takes the form of what we call the System Management Service. It secures all software components with certificates. It centrally manages those certificates. What's the one thing certificates do is they expire. And they typically expire at the most inopportune time, 3 o'clock in the morning on a Saturday when nobody knows what's going on, and all of a sudden your system doesn't work. How do you manage certificates that are going to expire in a 24/7, 365 critical infrastructure application? You must have something do it for you. And with Aviva, we have the certificate management service. It will automatically generate certificates to protect everything in your SCADA system from external intrusion. It will allow you to, if you wish to use externally purchased certificates so that they're publicly known, you can do that. But now you have one place to load the certificate. You load the certificate into the SMS server, and it distributes it to everybody who needs it. No one else offers that. It encrypts all inter-application communication with TLS. It uses TLS 1.2, and that's the basis of the operating system. It'll use 1.3 on the operating systems that support 1.3. These certificates can also be used to secure non-Aviva products. They can be used to manage your other things that can consume a certificate, but have no ability to have a management of that certificate for you. And everything becomes secured. Communication servers, OMI, InTouch, Historian, App Server, Cloud, Batch, MES, Work Tasks, Pi, OMI Web, all the functions can be secured now. But beneath that, we need a level of differentiating security. And I call this destination versus origination security. So SCADA rights are enforced at the command destination. It's no longer acceptable to put the SCADA enforcement in the cartoon or the graphic. In the world as we're evolving to, where we get self-authored graphics, where graphics are being generated by numerous actors in the system, we cannot rely on their compliance to a security model. And plus, it's totally indefensible because any API, any OPC interface, any third-party application, anything that was done that didn't have that level of protection on the graphic bypasses the security model. It must be centrally managed and engineered, one place to make the change. And it must be enforced in a distributed application, regardless of communication isolation. You cannot rely on two remote nodes being able to enforce their security if they cannot talk to the central control room where the Active Directory server is located. And all user actions must be recorded. This should not be an option in your SCADA system. You should not have to turn it on. You should not be able to turn it off. Everything should be recorded. All login attempts and failures, all writes to attributes, all attempts, all failures, all confirmed writes, all verified writes, everything must be recorded in a completely write-once immutable logging mechanism that can never be changed. And the security must be enforced at the attribute and tag level. It cannot be disabled. And we have 4 categories of security. We have configure, operate, tune, and view only. So configure is a category which means attributes are related to each other, such in the case of a scaling parameter. If I'm changing my scaling parameters from a user interface, I don't want the system to interpret half a change. So configure means I must complete all the changes before it will interpret the values. Operate and tune are parallel to each other. are just runtime categories. View only simply means no user interface or no API will ever change that value. It could be changed programmatically if we engineer it that way, but it can't be changed randomly from a user interface or an API. Secured write. It means that the person issuing the write must reconfirm that they're them. That may require a username and password. It may require a multi-factor authentication. Whatever you demand, that must be done. Just being logged in is no longer good enough. You can't walk away, go to the bathroom, and someone impersonate you. Verified write means two people must do it. This is the turn your key in the missile silo kind of thing. You know, why do we put two launch keys in a ballistic missile submarine? It's totally isolated. There's no way it's being penetrated. It's completely undetectable. Yet we want two sane people to agree that it is appropriate to kill 20 million people at this time. Now, that's morbid, but it also doesn't require the same level of authorization to run the microwave in the galley inside the submarine, right? It's different things have different levels of requirements, and you can't treat all data the same. Everything has different requirements, and you must be able to protect it to the appropriate level of protection that it needs. Now, we want to do MFA, and we're getting a lot of mandates from government agencies and things to say, hey, you must implement MFA. And now we have MFA, and the problem is most OT SCADA networks are not exposed to the cloud and don't have a 443 connection to the MFA providers that are in the cloud. Your Microsoft Authenticator is a cloud process. You must be connected to the cloud for that to work. And multiple intrusion protection devices must be crossed to get to the cloud. And as it should be, you shouldn't have to compromise all that. You shouldn't have to go to your network guys, say, hey, just punch 443 through all three firewalls. And the response to that is going to be very short and simple. And no, we're not going to do that, right? And opening a hole is unacceptable. So solution, Aviva has produced what we call DMZ Secure Link. It's a allow listed to only grant access to known endpoints. It can be securely managed from the Aviva Connect data services or software as a service in the cloud. And it's secured at rest and secured at motion. Its allow list is encrypted. It uses TLS in transmission. It denies all access to any other endpoint other than the things that it grants access to. It will allow you to route through the maze of intrusion protection devices. And it's got configurable ports and endpoints at every level. So you can weave through that maze of intrusion protection without compromising your intrusion protection. It enables MFA authentication when access does not exist on the SCADA network. We're the only vendor that offers this. DMZ Secure Link, single outbound port on the final link, no inbound connections allowed, all traffic is encrypted, anonymous HTTP proxy, and will allow you to chain them together, and will allow list, and the allow list is encrypted and managed from a known endpoint. You cannot construct this on premise. You must be able to manage this from a known endpoint in the cloud. And it gives access to MFA authenticators from networks that don't have access to MFA authenticators. Reliance on port restrictions. All software needs ports to communicate. It's just a fact. And it's an analogy to an office building with about 64,000 telephones. You can restrict it to only 10 phones in the building who you're allowed to talk to. But who's going to answer the phone? Who are you talking to? How do you know who you're communicating with? Yes, fewer ports simplifies firewall configuration and makes the system easier to manage. But port restriction is not a security policy. Sole reliance on that is a false sense of security. Certificates are required to ensure who is on either end of the communication and the phone call. Without that, it's just a fantasy. Industrial control system security, right? It must be looked at holistically. Never assume a system is impregnable. Defense in depth is critical. Obviously, you must be vigilant and monitor. You must understand the complete set of threats. Just don't think I can slap a data diode on top of my network and I'm going to be protected. That's the biggest mistake everybody makes. Design to mitigate those threats. Understand what they are. If you can't describe how your system works and how it protects itself, it's not protected. And when required, have a single point of disconnection so that I can pull the plug on any threat that may exist, right? Because access level security, which is what we get with many industrial protocols, is simply ineffective and not defensible. It's grant access or deny access. It's not possible to restrict individual data items. And many actors need various types of access. Just because you can change the product code on the bottling line from grape soda to cherry soda doesn't mean you can shut off the ventilation fans to keep the operators healthy, or you can change the high pressure alarm limit on the ammonia storage tank that runs the refrigeration unit. And write confirmation within these protocols is not possible on individual targets. So authorized access, secured rights, verified rights, these are not possible within protocols like OPC UA, OPC DA, within our SweetLink protocol, right? You must have an umbrella of protection on top of these things that allows you to differentiate what's going on. And then there's lots of industrial protocols, right? But they are all access only or no access if available. And a lot of these protocols are getting better where they're supporting certificate authentication. But once you get the certificate and you get authenticated, you can write to anything. You got to have something that can provide you a greater granularity than that. And as you transition into more generic industrial protocols, the same problem exists. So requirements of defensible security model. These protocols, these communications things, should be restricted to a single point of access. Only one client in your network should talk to them. You shouldn't have multiple clients talking to these things that can't arbitrate. Once you create a system like that can provide that restricted level of access and differentiated level of access, then yeah, that can share that information out. But the access to these things should be only from a known entity. And that known entity should be a service account. It should not be anything interactive. And all interactive logins on these nodes should be denied. Networks should be segmented apart from the process land so you don't expose these open protocols to general use. So there's a great need to get the data into the cloud, right? Our phones, we want to see information on our phones. We want to see information on our browsers. We want to get data in our hotel rooms. We want to see data when we're at home. We want to be able to monitor our system remotely. That connection should only be originated from the process LAN. And at Aviva, we do this. So we read a pressure, 35.4. We bring it into our SCADA system, and we bring that in securely with certificates and encrypted. And now it gets put in context in our SCADA system. And now it's known as tank A pressure, and we know it's 35.4. And we take that and we send it to our Aviva historian, and the historian records it. The historian then is the gateway to send this out to the cloud. The first thing the historian does is it separates the payload into two packages. The first package is the metadata describing the tag. It attaches it to a GUID. A GUID is called a globally unique identifier. It's an identifier that can never, ever, ever be repeated. Once generated, you can never get it again. So no one can ever spoof it. No one can ever fake it. No one can ever interpret it, right? The data gets attached to the GUID. And it gets passed through the maze of intrusion protection, sent up to our cloud storage, Connect Data Services. We store it in triplicate in the cloud. We encrypt it to the maximum level accepted by the Department of Defense. This is just the metadata attached to a GUID. We then take the data values. We reduce them to a number between 0 and 1. So all the data looks the same. Doesn't know if it's a voltage or a pressure or a temperature or anything, a flow rate. Every number looks identical, and it's just a number attached to a GUID. You have no idea what the GUID is for. You have no idea what the value represents in magnitude. That is then weaved up through the maze of intrusion protection. It's stored in a separate database in the cloud, in triplicate, geo-replicated to another data center over 650 miles away, stored in triplicate there, right? The threat to sending data to the cloud is not storage in the cloud. The cloud is an incredibly safe and secure place to save data if done correctly, such as the way we do it. However, the threat is someone would interpret it and change it before it gets there. So you make decisions on invalid information. So we protect it. It's called secured at rest, secured in motion. We protect it in both places. And when you want to see it, you get tank A pressure 35.4 completely, safely, securely. Now, the cloud is a great place. There's tremendous computational horsepower at the cloud, and it gives us the ability to analyze and put AI and machine learning and everything on this information. But because we originated this communication from our SCADA environment, we can consume this data back down that path safely, securely, with no threat of intrusion protection from the external sources. No threat of intrusion from the external sources, and give this data to our operators and enrich their experience with cloud-generated AI and machine learning of which they've never had before. So back to again, you must have certificate-based access only. You must be authenticated, authorized, approved, and archived, enforced at the destination of every command, completely independent of client configuration and protocol. Securely engineered network segmentation with intrusion protection, right? System platform enables the defense required.